Today I want to talk about what a continuous integration server should do. And it's all expressed in this code snippet. We will also touch on the subject of the power of pseudocode. So let's explore. Hi, I'm Rickard, and welcome to my channel. In my videos, I try to document what I'm working on and thinking about when it comes to programming. For the last year or so, I've thought a lot about continuous integration. I've made videos about trying to build my ideal continuous integration system. Then I found James Shore and read about what continuous integration is actually about, and I had to re-evaluate what I was doing. I've learned that continuous integration is more than just a tool. But at the same time, a tool can help you do continuous integration and do continuous integration well. And I think I've figured out what a continuous integration server should actually do. It's not what I tried to build before. It's actually a lot simpler. It's so simple that it can be expressed by this snippet of pseudocode. So let's have a look. First of all, I want to take some time to appreciate how many details can be captured in a piece of code. Explaining how this continuous integration system works would take many more words and sentences. Being able to express something concisely in a few lines of code is so powerful. So let's unpack this code and see all the details it captures. First of all, the purpose of the CI server is to integrate code from a branch in a repo. How do we do that? First, we clone the repo and then we merge the given branch with the main branch. If that works, the branch is integrated. However, we don't want to push broken things to the main branch. So we also make sure the test suite runs successfully. This will run some command defined in the repo. If that works, we push the code to make the new main branch available to everyone else. Finally, the lock ensures that only one branch can be integrated at a time. This ensures that everything we push to the main branch has been tested and works. And that's it. I think this is the core operation that a continuous integration system should perform. And I think by just reading this pseudocode, you can imagine how this system would actually work in practice. There are of course many details missing, but the essence of the system is captured in this pseudocode. Let's have a look at some variations and see what it does to the system. Here we have included two test suites. It's easy to see that only the first test suite will block code from being integrated. This can, for example, be used to execute long-running performance tests that are not critical for basic operation, and we don't want to block other people from integrating their code while they are running. Let's have a look at another one. This change requires you to know a bit about how Git works. It will fail the merge if the branch you're trying to merge is not based on the latest version of the main branch. So if someone else integrates some code that you don't have locally, you need to perform the merge locally first. This pseudocode uses Git as an example, but most likely we want our continuous integration system to work independently of source control system. So let's see how we can express that in pseudocode. Here we have replaced Git commands with a repo object instead that has operations that we want to perform. This makes the code a little more generic at the cost of making it a little bit more abstract. If you're working with Git, you have to look at the details of how the repo object works to figure out the exact operations that will be performed during an integration. What we have looked at today has been pseudocode, but the examples we have looked at have not been that far away from actually being executable. So what if all our code looked like this? So like having the general solution to the problem expressed in something very close to pseudocode, and then having all the details in lower level methods. Then our code base, we could read our code base sort of like a knowledge base to learn how to solve problems in a particular domain. Do you think this would be possible? Or will the code base always be cluttered with code-specific things not related to the problem domain? Anyway, that's it for now. I'll see you in the next video.